going to be similar objects. Do you remember when we did congruent triangles, and congruent means the exact same? Come on with me on that. Congruent, exact same. Similar means they look kind of the same. They have the same shape, but a different size. So same shape, but a different size. They are scaled. One is going to be bigger than the other. I always call it like the mommy shape and the baby shape. So they look the same, but one is just larger than the other. So they have what's called a scale factor or ratio. So a scale factor or what's called a ratio. One is just bigger than the other. They look the same, though. They're called similar, is what it's called. So if you look at the two cones that are there, do you see how they look the same, but one's bigger? Okay. This one has a height of 3. This one has a height of 6. How much bigger is this one than this one? 2 times. It is twice as big. If you do 3 times 2, you're going to get 6. So for this one, your scale factor is 2. If you do 3 times 2, you're going to get 6. The other thing you could do is 6 divided by 3 equals 2. That's called a ratio. When you make a fraction, ratio is a fancy word for fraction, is all that means. When you hear ratio, it means something divided by something else. Okay? Now, before we flip over and just do a couple problems, this is the main thing that you have to remember. There's 3 levels to this. Your dimensions, which if they say the height or the radius or the circumference or like any of those things, that's just the length of part of the shape. The dimensions are the first power. They are one-dimensional. Dimension. All right, now when you talk about area, so surface area, lateral area, stuff like that, that is the second power because it is two-dimensional. Two-dimensional, like a flat surface, like the floor of this room is two-dimensional. And then if you do a volume, that would be the third power because a volume is 3-dimensional. We only have 3 dimensions. Length, width, height. So we have a first power, second power, third power. We're going to flip over and do a few of these on the back. Use our calculator. Basically, if you understand first, second, and third power, you're going to be fine. All right, and you have to read. You have to be able to read the question. There are a few of these that I thought were like needlessly difficult that we're going to skip. We're going to not do 3. I'm going to tell you what they are ahead of time. We're going to not do 6, and we're going to not do 9. Oh, that's actually kind of funny how that turned out. 3, 6, and 9 we're going to skip. 3, 6, 9. We're going to skip those ones. We'll do all the other ones. So this is the ratio of the heights. A height is just a dimension. That's just a length. That's one-dimensional. Of 2 pyramids is 3 to 5. What is the ratio of their volumes? What power did I just tell you volume was? Third. So you're going to take this 3 to 5 and take them to the third power. That's it. Now, so I don't have to click over to the calculator. Could you type 3 to the third power in your calculator? Yes. Okay, I'm just going to go ahead and tell you that that comes out to 27. And then 5 to the third power is 125. But that's your answer. You read it. It says volume. You're like, okay, volume is to the third. And you just take it to the third power. That's it. Okay? But you do have to read. So sometimes it can be hard. All right, it says dimensions are divided by 8. How many times smaller is the volume? Volume means which power? Third. Okay, so you're going to take 8 to the third. Could you type 8 to the third into Desmos? Like you could do that, right? I'm not going to go back and forth to the calculator if you feel like you've got it. That will come out to 512. And it said how many times smaller? So it is 512 times smaller. That's a lot. If you have an object and you shrink it to 512 times smaller than it was, it would be like itty bitty. Do you get what I'm saying? Like teensy tiny. All right, ratio of areas. Area is what power? You can flip over if you need to. Second, okay, is this. Here's the $1 million question. How do you undo a second power? How do you undo a squared? And hint, the word square is in this answer. How do you undo a squared? Square root. Perfect. We're going to take our 36 and our 49, and we are going to square root them. Could you type square root into Desmos? There's two ways you can do it. How could you type a square root in? You can do like in the menu, find it in the menu, or you can type SQRT. You guys text a lot and do abbreviations, so like work with me, SQRT. Anyway, I'm just gonna go ahead and tell you that that comes out to 6. Well, actually, I'll ask, does anyone know the square root of 49? Just throwing it out there. 7, good job. So we got 6 and 7, 6, 7. All right, and it says, what is the ratio of their volumes? Volume is which power? Third. Good. So we're going to take both of those to the third. 6 to the third power is 216. I believe you could type that in. 7 to the third power is 343. I just ran out of room and I apologize, but it's 216 and then 343. You're just taking those numbers to the third because it said volume. This is going good. We'll just do a couple more. Actually, you guys are all really listening to me, so I'll just maybe do like 2 more. Let me see. Which ones would be good? Let's do number 7. It says the dimensions are quadrupled. Quadrupled means you've multiplied by 4. Like quadruplets, heaven forbid, would mean you'd have 4 babies, right? So quadrupled, how many times larger is area? So 4 is quadrupled. What power is area? The second. Does anyone know 4 squared? It's 4 times 4. Again, I'm just throwing it out there because I don't feel like going to the calculator. It is 16. Good. So it is 16 times larger. Yeah, it is crazy. It's got, like, can you imagine if you took me and made me 16 times bigger? I wouldn't even fit in this room, you know? All right, and then let's do either 10 or 11. Which one do you want? Let's do 10. It says surface area. It says surface area of a cube is this number, 384. The dimensions are doubled means 2. Okay, thank you, one person. So we're going to take 384 times 2, but hold on. It was area. Area means what power? The second. It's 2-dimensional. I don't know what that is off the top of my head, but I have it written down here. And I believe you could type that in the calculator because you guys are pretty good with your calculator. It comes to 1,536. So basically the takeaway is this. Dimensions are which power? First power. Area is second. Volume is, that's the takeaway. Okay?